I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solutions of three problems that are taken from CSIR National Eligibility Test held in the month of December in the years 2018 and 2019. These questions are from the section Real Analysis and they are related to the concepts of sequences and series. These questions are suitable for all these examinations. Right. This is the question from analysis with the QID, question ID 1879801764 for 3 marks from the section B, and this has appeared in 2019 December and it is related to the sum of the series. The given question is, what is the sum of the following series? 1 by 2 into 3 plus 1 by 2 square into 3 first bracket plus second bracket 1 by 2 square into 3 square plus 1 by 2 cube into 3 square plus etc. nth bracket 1 by 2 power a dot multiplied by 3 power a plus 1 by 2 to the power of a plus 1 multiplied by 3 power a plus so on and so forth. Instead of a, we take it n. We are used to it. Right. We are given 4 options. Right. These are the 4 options. Let's now discuss the solution of the problem in detail. This is the given series. So in each bracket there are 2 terms. If you see the first terms in each bracket, that forms one series plus the second term in each bracket 1 by 2 square into 3 plus 1 by 2 cube into 3 square plus so on and so forth. That forms etc. That forms another series. So let us break down. Before that, let S be the sum of these series. Right. Now write it as sum of 2 series. The first one is 1 by 2 into 3 plus 1 by 2 square into 3 square plus 1 by 2 power n into 3 power n plus so on and so forth. The second series is 1 by 2 square into 3. That means the second terms of each bracket plus 1 by 2 cube into 3 square plus so on and so forth 1 by 2 power n plus 1 into 3 power n plus so on and so forth. Right. You keep the first series as it is. In the second series, what you observe is you take 1 by 2 common. 1 by 2 common. So the first as it is plus 1 by 2 is taken common and it turns out to be the first series. The first series. So the first series plus 1 by 2 times the first series. So the first series is common. So it will be 1 plus 1 by 2 multiplied by the first series. 1 plus 1 by 2 into 1 by 2 into 3 plus 1 by 2 square into 3 square plus so on and so forth. 1 plus 1 by 2 is 3 by 2. 1 by 2 into 3, 1 by 6 plus 1 by 6 square plus 1 by 6 to the power of n plus so on and so forth. What is it? It is a geometric series with the first term a is equal to 1 by 6, common ratio r is equal to 1 by 6 which is less than 1. Therefore, the sum of the series up to infinity is a by 1 minus r because the common ratio is less than 1. Right. This is equal to 3 by 2 into A 1 by 6 by 1 minus R 1 minus 1 by 6. That is after simplification 3 by 2 multiplied by 1 by 5, that is 3 by 10. Where is it? It appears against option 2. Therefore, option 2 is true and the answer to this question is option 2. That is the detailed discussion of the solution of the given problem. And it is a very simple and straightforward question. Right. We move on to the next question. Right. This question is for 3 marks. And this question is from the National Eligibility Test in the month of December 2018. And it is related to convergent series. The given question is, let x be a real number such that mod x less than 1, which of the following is false? We have to find out a false statement. That means 3 of them are true and 1 of them is false, and you have to identify that. Options. Option 1, if x belongs to Q, this set of the field of rational numbers, then sigma m greater than or equal to 0 of x to the power of m also a rational belongs to Q. Option 2, if sigma x to the power of m belongs to Q, then x belongs to Q. That means this is if and only if almost. Right. Option 3, if x does not belong to Q, then sigma m greater than or equal to 0 m x to the power of m minus 1 does not belong to Q. Option 4, sigma m greater than or equal to 1 x power m by m converges in R. Let's now discuss the solution of the problem in detail. We have x, a real number, and it is given mod x less than 1. Let us take the option 1 and option 2 simultaneously. Right. Now, consider the series sigma m greater than or equal to 0 x to the power of m expanded. M is equal to 0, x power 0 is 1 plus x square plus so on and so forth, x to the power of m plus so on and so forth. So, it is again a geometric series with first term a is equal to 1 and the common ratio r is equal to x, and it is given as mod x less than 1. Therefore, its sum is a by 1 minus r, that is equal to 1 by 1 minus x, because it is mod x is less than 1. Agreed. So, the sum of this series, that is sigma m greater than or equal to 0 x to the power of m, is 1 by 1 minus x. Right. So, let us take first consideration in the first option. So, x belongs to Q. Then 1 minus x also belongs to Q. Then its reciprocal also belongs to Q. And 1 minus x not equal to 0. Of course, x is not 1. Mod x less than 1 means x not 1. So 1 by 1 minus x belongs to Q. Therefore, the sum is a rational number. So, thus you have proved when x belongs to Q, its sigma x to the power of m is also a rational number. Thus, option 1 is true. But we have to find out the false statement. Right. This is not our answer. Right. Now, conversely, you take your series. Its sum is 1 by 1 minus x. Suppose that is a rational number. 1 by 1 minus x is a rational number, means 1 minus x is a rational number. Agreed? 1 minus x is a rational number means x is rational. So that means the sigma is belongs to Q. Sigma x to the power of m belongs to Q. Then x also belongs to Q. So this is precisely option 2. Therefore, option 2 is also true. But we have to find the false statement. Let's move to the next slide. Now we consider option 4. Sigma m greater than or equal to 1 x to the power of m by m. So this is a series converges in R. Agreed. Now x belongs to R mod x less than 1. So x can also be negative. When x is negative, the terms are positive and negative, so on and so forth. Therefore, we cannot use directly the ratio test. The ratio test, normally we use it for the terms of positive terms. But ratio test still can be used with modulus. Therefore, now limit m tends to infinity of mod of um plus 1 by um. That is equal to limit m tends to infinity of m plus 1th term is x to the power of m plus 1. 1 is missing here. M plus 1 by m plus 1 by x to the power of m by m. After cancellation, you will get limit m tends to infinity of m by m plus 1 into mod x. So mod x times limit m tends to infinity of 1 by 1 plus 1 by m. As m tends to infinity, 1 by m tends to 0. So it is the limit is 1. So you get mod x. But we are given mod x less than 1. So mod x less than 1 using the ratio test. So since mod x less than 1, by ratio test, sigma m greater than or equal to 1 x to the power of m by m converges in R. Agreed? They converges. So option 4 is true. Now to find the false statement, so out of the 4, these 3 are true. So the remaining one must be the false statement. By elimination method, the false statement is option 3. So the answer to this question is option 3. That is, option 3 is if x does not belong to Q, then sigma m greater than or equal to 0, mx to the power of m minus 1 does not belong to Q. What is this series? This is series, the original series. Differentiate it, you will get this series. Right. So that by elimination, what we say is this is the answer. That is the option 3. But however, our students want a proof for that. Right. We do it now. Option 3. If x is an irrational number, then sigma m greater than or equal to 0, mx to the power of m minus 1 is also an irrational. Now consider the series, the given series. Sigma m greater than or equal to 0, x to the power of m, 1 plus x square plus so on and so forth. And it is a power series and converges to 1 by 1 minus x when mod x less than 1. And it may be mod x less than 1. Therefore, its radius of convergence, capital R, is equal to 1. So, inside the radius of convergence, the series also converges uniformly. Therefore, we can use the term by term differentiation is valid in mod x less than 1 inside the circle of convergence, and that is the term by term differentiation is sigma m greater than or equal to 0. The derivative of x to the power of m is mx to the power of m minus 1 is the derivative of 1 by 1 minus x is 1 by 1 minus x whole square. Right. Now, suppose you take x is equal to 1 minus 1 by root 2. This is an irrational number and is less than 1. Mod x, when you take the modulus, it is less than 1. It is less than 1. It is less than 1. So, take the derived series. In that, substitute x is equal to 1 minus 1 by root 2. 1 minus 1 by root 2. 1 minus 1 minus 1 by root 2. 1 cancels and 1 by root 2 whole square is 2. So 2 is a rational number. It is not irrational. So the statement that is given in option 3 is not true. Option 3 is false, and we have to find out that that statement which is a false statement. Therefore, the answer to this question is option 3. That is the detailed discussion of the solution of this problem. Right. Let's move to the next question. This is also the question that has appeared in 2018 December, and it is for 4.75 marks. That means from the part C, it is related to the uniform convergence of sequences. The given question is, for n greater than or equal to 1, consider the sequence of functions fnx is equal to 1 by 2nx plus 1, gnx 1 by x by 2nx plus 1 on the open interval 0 to 1. Consider the statements. Statement 1. The sequence fn converges uniformly on the open interval 0 to 1. Option 2. The statement 2. The sequence gn converges uniformly on the open interval 0 to 1. Then we are given 4 options. Option 1. Statement 1 is true. Option 2. Statement 1 is false. Option 3. Statement 1 is false and statement 2 is true. Option 4. Both the statements 1 and 2 are true. Let's now discuss the solution of the problem in detail. We have the sequence of functions, sequence fn and sequence gn. We have fnx is equal to 1 by 2nx plus 1 and gnx is equal to x by 2nx plus 1. X belongs to the open interval 0 to 1. N is a natural. N belongs to the set of natural numbers. Let's now talk about its pointwise convergence. That means for each x belongs to 0 to 1, limit n tends to infinity of fnx is limit n tends to infinity of 1 by 2nx plus 1 is 0 for all x belongs to 0 to 1. That means fnx, the sequence fn converges pointwise to the 0 function, that is f of x. That is f of x is equal to 0 for all x belongs to 0 to 1. And so also for all x belongs to 0 to 1, limit n tends to infinity of gnx is equal to limit n tends to infinity of x by 2nx plus 1 is equal to 0. This also converges pointwise to a function g of x, that is g of x is equal to 0 for all x belongs to the open interval 0 to 1. Thus, the sequences fn and gn converges pointwise to f and g respectively, where f of x is equal to 0, g of x is equal to 0 for all x belongs to 0 to 1. That means they are 0 functions. Agreed. We move to the next slide for the discussion of uniform convergence. So we talk about the uniform convergence of fn first. So for that, we recall a test, a famous test for uniform convergence of sequence of functions. This test is famously called as M test. Let D be a subset of R. Let Fn be a sequence of real valued functions pointwise convergent to a function f. This sequence converges pointwise to f on D. Let Mn, the supremum of mod of fn x minus fx, where the supremum is taken over all x belongs to D. Then the sequence fn is uniformly convergent on D to f if and only if limit n tends to infinity of mn is equal to 0. Right. Now we let mn be the supremum of x belongs to 0 to 1 of mod fn x minus fx. Right. That is equal to supremum of x belongs to 0 to 1 mod fn x is 1 by 2nx plus 1, fx is 0, so is this one. So supremum of x belongs to 0 to 1 mod of 1 by 2nx plus 1. How this supremum is 1? We have written 1. That means the supremum on the interval 0 to 1 is 1. How? Now you see 1 by 2nx plus 1 is here. So this value will be 1 by 2nx plus 1 will be minimum. No. It will be maximum. It will be maximum for x is equal to 0. When x is equal to 0, it takes the denominator takes the least value. Then 1 by the denominator will be the supremum. So that means for x is equal to 0, supremum is attained, and that is 1. Now, limit n tends to infinity of mn is 1 for all n. So, limit n tends to infinity of mn is 1, which is not equal to 0, which is violating this theorem. Therefore, by m test, the sequence fn is not uniformly convergent on the open interval 0 to 1. Thus, the statement capital 1 is not true. Now, we talk about uniform convergence of the sequence Gn. Let Mn be the supremum of x belongs to 0 to 1, mod of Gnx minus Gx, that is equal to supremum taken on supremum of mod of x by 2 x plus 1 by, and the supremum is taken for all x belongs to 0 to 1, and g of x is 0. That is why mod Gnx only coming. So what is the supremum of this? That is the question. So to calculate the supremum, we have given this in the snippet. Let us call this as y is equal to x by 2nx plus 1. Take its derivative with respect to x. Then it is 1 by 2nx plus 1 whole square. Do it. Now this will imply y prime is greater than 0 for all x belongs to 0 to 1. That means y of x is a strictly increasing function on 0 to 1. When it is a strictly increasing function on 0 to 1, y of x, y will attain its maximum at x is equal to 1 at this end point, because it is increasing. Because it is increasing, it attains minimum at 0 and maximum at x is equal to 1. So y attains maximum at x is equal to 1, and the maximum value is y of 1. That means for x you substitute 1. So 1 by 2n plus 1. So come here, the supremum is 1 by 2n plus 1. So limit n tends to infinity of mn is 1, limit n tends to infinity of 1 by 2n plus 1 is 0. So the conditions for m test are satisfied. Therefore, by m test, the sequence Gn is uniformly convergent on the open interval 0 to 1. So thus the statement 2 is true. Let's look at our options. Our statement 1 is not true. That means statement 1 is false and statement 2 is true. That is appearing precisely against option 3. That is statement 1 is false and statement 2 is true. So the answer to this question is option 3. That is the detailed discussion of the solutions of those 3 questions what we have chosen for discussion for today. I am sure that you have understood the solutions of these problems. Thank you for watching my video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We hope to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.